Hey guys, this is lesson 4.1 for pre-algebra. 4.1 is divisibility and factors. So you need to title your paper 4.1, divisibility and factors, and then you need to write down this highlighted word, divisible. So one integer is divisible by another if the remainder is 0 when you divide. So 18 divided by 3 is 6. 18 is divisible by 3. You can test for divisibility using mental math. So it's just kind of like how we talked about compatible numbers. It's the same type of thing. Here's a key concept. Divisibility rules for 2, 5, and 10. So you want to write this down in your notes. Divisibility rules for 2, 5, and 10. So there's 3 bullets. It's divisible by 2 if it ends in 0, 2, 4, 6, and 8. I'm pretty sure everybody knows that one. It has to be an even number divided by 2. It's divisible by 5 if it ends in 0 or 5. And if it ends in a 0, it's divisible by 10. So right off the bat, if I showed you a number, you would be able to tell if it was divisible by 2, 5, or 10. Even numbers end in 0, 2, 4, 6, 8 are divisible by 2, and odd numbers that end in 1, 3, 5, 7, or 9 are not divisible by 2. All right, so try these 4 problems, push pause, and then we'll go over them. All right, so it says, is the first number divisible by the second, and explain. So is 160 by 5? So you would say yes, because it ends in 0. Anything that, if you go back to your divisibility rules, if it's divisible by 5, if it ends in 0 or 5. So 56 by 10. So no, because it doesn't end in 0. 10 is only divisible by things that end in 0. 53 by 2. This is no, because 53 is an odd number. And then the last one, 1,118 by 2. And this is yes, because 1,118 is even, so it is divisible by 2. All right, pretty easy. Now, to see a pattern for divisibility by 3 and 9, compare the answers to the questions asked in this table. So, to see if it's divisible by 3 and 9, what you do is you take the number 282, and you add up the digits. So you do 2 plus 8 plus 2. So I'm going to add up each digit by itself. So 2 plus 8 is 10, plus 2 is 12. And then you say, is the sum divisible by 3? So is 12 divisible by 3? Yes, 12 divided by 3 is 4. Is 12 divided by 9? No. And then it says, is the number divisible by 3 and 9? So notice here, if I add it up, and then if I can divide it, if I can divide the smaller number by 3, yes, then 282 is divisible by 3. If I add it up and I get 12, it's not divisible by 9, therefore 283 is not divisible by 9. So that's how that works. So if you look at, you don't need to copy that down, but you do need to copy down the key concept. So it says, an integer is divisible by 3 if the sum of its digits is divisible by 3, and 9 if the sum of its digits is divisible by 9. All right, so quick check. Try these 4 if they're divisible by 3 and 9 and see, and then we'll come back and we'll check our answers. All right, so 64, is that divisible by 9? So that one you kind of know off the top of your head, no, because 63 is divisible by 9. But what you do is you add 6 plus 4, and that's 10. So then, no, it's not divisible by 9. Well, okay, we have to explain. So no, because 10 is not divisible by 9. All right, 472 by 3. So I'm going to add 4 plus 7 plus 2. 4 plus 7 is 11, plus 2 is 13. Can 13 be divided by 3? No. 13 is not divisible by 3. Next one, 174 by 3. So 1 plus 7 plus 4. So 1 plus 7 is 8, plus 4 is 12. And is 12 divisible by 3? Yes. 12 is divisible by 3. And then lastly, 43,542 divisible by 9. So 4 plus 3 plus 5 plus 4 plus 2. 4 plus 3 is 7, plus 5, so that's 7, plus 5 is 12, plus 4 is 16, plus 2 is 18. So 18 is divisible by 9. So that's a yes. All right, real world problem solving. So this is our last example. There are 20 students singing at a school concert. Each row of singers must have the same number of students. If there are at least 5 students in each row, what are all the possible arrangements? So there has to be 5 students in each row. So I could have one row of 20. So what you do is you list out all the factors. Factors, if you remember what this title was, divisibility and factors, this is the factors part. So you list out the factors, and then you can have one row of 20. So all 20 of you would be in the front row. Okay, that would at least have 5 in a row. 2 rows of 10. So that would at least have 5 in a row. I was going to try and copy that, because there's 10 in each row. Or 4 rows of 5. So that has at least 5 in a row. So you have 3 different combinations. So let's try a couple of these. List all the possible factors of each integer. So you can do that. And then it says, what are the possible arrangements for example 3 if there are 30 students singing in the choir? So let's try A, B, C, and D. Push pause and then come back and I will go over it. All right, list all the positive factors. So 10, I have 1, 2, 5, and 10. 21, I have 1, 3, 7, 21. 24, I have 1, 2. Now here's where it gets a little bit trickier. 3 times 8, 4 times 6. So then I got to go backwards. 1, 2, 3, 4, 6, 8, 12, 24. And then D, I have 31. And that is a prime number, so it's just 1 and 31. So now, for how many possible arrangements if there are 36 students singing in the choir? So I list out my factors, 1 and 36. Whoops. 2 and 18. 3 and 12. 4 and 9, and then 6 and 6. So So I have all of my factors listed out. Now I want 5 in a row. So I could have one row of 36 students. That would be a lot in one row, but there would be at least 5 in that row. I could have 2 rows of 18. So I'd have 2 rows, and there'd be at least 5 in there because there'd be 18 in each. I could have 3 rows of 12. So there'd be 12, 12, and 12. That would at least have 5. I could have 4 rows of 9. So a row of 9 kids and a row of 9 kids. You get it? And then 6 rows of 6. So there are 1, 2, 3, 4, 5 options. Now, I can't keep going and say, oh, I could have 9 rows of 4. I can't have 4 in a row because they wanted at least 5 in each row. So I can't redo each of my sets of numbers. So that's where I have to stop once I hit the 5 part. So that is it for your notes for 4.1.